Okay, this is circuit 3, photoresistor for the activity from the activity guide for SparkFun Tinker Kit. It is real similar to the last one where we were using the potentiometer. However, this time we're going to be using a photoresistor as our sensor. So right down here you can see where the photoresistor is instead of the potentiometer. And if we look at our parts list, right, we have the breadboard, and we've got the red board, and we have the 7 jumper wires, which I'll show you in a second, are all actually in the same exact place as the last experiment. So I just left them in place. If you've taken it apart, you're welcome to, obviously you can just put it back together in the same format. We need, it says one 330 ohm resistor, and then we need one 10K resistor, right? So now we're going to get that different resistor out of the box. So, oops, I got to track that one down real fast. Here we go. All right, so we need a 10K. So we need that photoresistor, which is this little guy there, and we need a 10K. Okay, and if you look at these closely, their pattern doesn't match, right? So they've also come out of a different box or a different bag with a different label on them to show what their resistance is. Okay, so those are the only two parts, and I've already I took away the potentiometer like I said a minute ago, and I just left the rest of it in place because all the rest of it is going to be the same exact thing. Okay. So as we scroll down through this thing, we've got a new component, right? So new components, we have the photocell we want you to know about, and then we also have now, we're dealing with analog to digital converters, which is similar to what we did last time, and then again the voltage divider. So again, reading these little highlighted pieces will help you get a better understanding of what's going on in the background. I thought I turned that off. All right. Okay. So again, make sure you read. Don't just skip down to the bottom. Make sure you read what a photocell is, understand what a photocell is. You're going to want to know these things for future projects that we're working on. Understand analog digital converter and understand voltage dividing. Okay. Right, so the hookup guide, we can look from the last time, we have the LED in the same place, the resistor, the cables, these are all of that part is all exactly the same. This blue wire and these two wires are exactly the same as well. So all of the wires stay in place. What we change is this little setup right here. So you can see the photoresistor is on the wire, this red wire, and over to the blue wire. And then there's a resistor, 10K resistor, on the blue wire and the black wire. That's essentially the only changes that have to be made from the last experiment for this one to function. So if I just do something like that, where I've got the photoresistor is on the first wire and the second wire, and then I'm going to take my 10K resistor here, and I'm going to squeeze them a little closer because we got to get it tight. We need to be on the middle wire, so I need to be in the middle wire right here. So wire, resistor, photoresistor. Okay, and then the photoresistor or the resistor is over here on the this blue wire here, the bottom wire. Okay, which on your map here is the center here to that center to this wire. Okay, so this is set up that way. We can kind of see that from the picture there. Okay, I've got this wire and this wire and this wire all the same line, right? So wire, wire, wire. I've got the second wire, I've got it over here on 25, and this one's on 25. That would be this wire and this wire. And then here on this one, I've got this green wire and the photoresistor here. Okay, so with those pieces in place, I've done the wiring for this job, and that's because if you already took it apart, right, and then just put it back together the way it was, just follow the map. Again, you can double check here on the hookup table if you really wanted to. We're going to copy the code over. Okay, let's look at the code real fast. We're initializing the photoresistor. So we're setting the variable photoresistor and we're setting it to 0. And we're initializing the threshold variable and we're setting it to 750. Okay, and then in our setup loop we're going to turn on the serial connection and we're going to set pin 13 to output. So those are real similar to last time. So we'll be able to use the serial monitor to see the values of the photoresistor. All right. In the loop, we are going to read the position of the knob, right? So photoresistor, and it's not really a knob, it's the photoresistor. We're going to do an analog read, right? So that's going to be this blue wire right here, reading off of this sensor. And we're going to apply that, whatever that reading is, to the variable photoresistor, and then we're going to print the variable photoresistor in our serial monitor. Let's go ahead and... I was going to turn it on already, but we don't have communication set up yet because I'm unplugged. Right, you can see I'm unplugged here. All right. And then down here, after we've read that, right, so we're going to loop, we're going to read it, and then we're going to go down here and say if the photoresistor is less than the threshold, right? Do you remember what the threshold value was? All right. If we don't remember what the threshold value was, it was set up here as 750. Okay, so if the reading from this is less than 750, we're going to turn the light on. Okay, meaning if it's covered in any way, it'll turn the light on. Okay, if it's not less than that, so if it's above that 750 threshold, then we're going to turn it off. Right, that means it's daylight. We don't need the light. Like, so this is essentially creating a night light. That's photosensitive, that's light sensitive. Okay, then we're going to delay for 100 milliseconds and then we're going to start the whole loop over again. We come back to the top, we'll read the photoresistor, we'll print the value, we'll check it against this this equation. If it's below or above the threshold, it'll either, if it's below, it'll turn it on. If it's above, it'll turn it off. Okay, so that should be what we should be able to do. We should be able to run this. I'll turn on the serial monitor so we can see where we're at, and then we can see if the LED behaves the way we expect it to, which is if I can cover it enough, then the light should turn on, and when I uncover it and the value goes above that threshold, the light should turn off. All right, so let's go ahead and get this thing plugged in real fast. All right, so we got that plugged in. And we want to go ahead and just run this sketch. I got to save it. So photo resistor. Okay. So we're compiling the sketch, sending the sketch over. All right. So this, here it goes right here, transmission. All right, and it's okay, that's done. The light didn't come on, right? I'm assuming probably because we have too much light right now. So let's see what the light reading is. See if we're getting a light reading. So we're getting a light reading in 870 range, right? So even if I do it like this, I probably get a little bit higher, right? So 902 because I have a light right over here. Okay. Right. So we've got a reading of 908. If I can get this reading to drop below 750. Okay, if I can get it to drop below 750, I should be able to get it to turn the light on. So I'm going to cover it. Okay, so I covered the resistor and the light came on, and you can see I'm only getting 10, 11, 9, so really low readings. So I can bring this up. Right, so I'm seeing a little bit of light, and then as soon as it hits that 750 mark, right, it turns off. You can also kind of maybe do this, right? So below 750, above 750, below. Right. So that's what we're trying to get to, and what we're using is this photoresistor to measure the light and then do something based on the light. Okay, so in our case we're just turning on a night light, right? So that's pretty straightforward. So think like if you have security lights on your house or your apartment, right? and they come on at night, and that's because there's a photoresistor in their system, and when it gets to a certain amount of light they turn it on. And I can adjust that, right? I can say, well, I think it's light as long as it's, say, above 500, right? So I can set that threshold to 500, and then I'm going to rerun this. So we got it transmitting over here, and now you start my readings again. So if I kind of see how it's at 700 now, so it's below that 700 mark, but it's still on. Oh, I dropped it down. All right, so it's not on yet until I get to below 500. Right, and it's hard to get to below 500 just by doing this. So I've got to actually kind of cover the sides of it to get it to 500. Right, so you can adjust the sensitivity of how that light comes on and off, right, based on your threshold values. All right, and that is circuit number 3, photoresistor. There's some more explanations down here. There's some new lines of code. So we're doing this if logic, right? So the if-else logic, which you should be learning about the if-else logic in Automate the Boring Stuff. You're going to learn it in a Python format, but if, elif is that's what's going on here. If-else. And then also then the logical operators where we're actually we're making using math to make a decision. Okay. And then there are 2 additional challenges. There's a response pattern, and then replace the 10K resistor with an LED and see what happens. Okay, to see what the effect of not having that 10K resistor in place is. Okay, so there's some other cool stuff that you can do with this assignment as well. I hope that helps, and off we go to the next one.